So in this video, we're going to talk about how to add and subtract rational expressions. So rational expressions are just like fractions. So that means that when you add or subtract rational expressions, you need to make sure to have a common denominator. So let's first look at some problems where we already have a common denominator, right? Or where we have a like denominator. So when you're adding, you're just going to go ahead and combine the like terms in both numerators. When you're subtracting, we need an extra step. What we're going to do is we're going to multiply all the terms in the second numerator by -1, because remember, it's kind of like when we subtract polynomials. Remember, we switch it to addition and then add the opposite. And then we're just going to combine like terms and the denominator will stay the same. And remember, we have to always simplify our final answer, because remember, in simplifying rational expressions, what we did is factored everything and canceled any common factors we had left. So let's look at this first example. So you can see here, I already have a common denominator, right? So both of these denominators are x plus 5, so I'm just going to go ahead and add my numerators together. So that means I'm going to be adding 3x squared plus 15x, and that's going to stay over the common denominator, which is x plus 5. So now, because this is a rational expression, I need to go ahead and simplify whenever possible. So I'm going to factor the numerator to see if I can simplify anything. And so when I factor the numerator, well, notice that both of these terms have a GCF, right? The GCF is 3x, and I'm going to go ahead and factor that out. So I'm going to divide a 3x out of both of these terms. And when I do that, that is going to become 3x times x plus 5. Okay, so we're going to go ahead and factor that numerator to 3x times x plus 5. And you'll notice that when I do this, this rational expression can actually be simplified, right? This x plus 5 and x plus 5 will cancel, and that's going to leave me with a final answer of just 3x. So now let's try this example. So here we're subtracting, right? So once again, we have a common denominator, so let's go ahead and subtract. Well, when I subtract, it's going to look like this. I'm going to combine the numerators, but I'm going to switch that subtraction to an addition, and then I'm going to add the opposite. So basically, I'm going to take that second numerator and multiply every term by -1, just like what we did when we were subtracting polynomials. So this -1, when it distributes, is just basically going to switch the signs on all the terms in the second numerator. So I have 7x plus 1, and then it's going to be minus 2x minus 3. And that's going to stay over the common denominator, which is x minus 4. Now I need to combine like terms that I have. Well, notice I have a 7x and a minus 2x, and those will combine, which gives me 5x. I have a plus 1 and a minus 3, and those will combine to become minus 2. So I have 5x minus 2 over x minus 4. So I'm going to check and see if it can be simplified, but I can't factor anything out here, so this is already in fully simplified form. So now let's look at some examples where we have unlike denominators. When we have unlike denominators, we have to do a little bit of extra work. So what we're going to do is just go ahead and fully factor the denominator of both expressions. And then what we'll do is we'll determine what factor is needed to have a common denominator. And then we're going to multiply the numerator and denominator of each expression by a fraction that equals 1. And remember, that means same numerator, same denominator, and that'll help us obtain the like denominators. Once we have the like denominators, we can go ahead and add and subtract like we did in the previous examples. So let's first try this example. So you can see here I have actually 3 rational expressions, right? So my first goal is going to be to factor the denominators. So I'm going to write this as 3b squared over 2 times a squared plus 5b over, well, that's just 3 times a, right? And then minus 1 over, and 6, I'm going to write it as 2 times 3 and then a cubed. And now what I'm going to do is I'm going to go ahead and think about what would be my common denominator. So what my strategy here when I do this is I just go ahead and take my first denominator, okay? So the first denominator is like 2 times a squared. And then what I do is I go to my other denominators and I add in factors that I haven't already written. So like you see here, I have a 3, so I'm going to go ahead and put a 3 factor also. I don't need to have a because I already have an a squared written here, okay? See here we have 2 times 3. Well, I already have 2 times 3, so I don't need to write it again. Okay, so that's the strategy here. You don't write anything that you already have. Here I have an a cubed and I only have an a squared. We actually want to go with the highest power on every variable. Okay, so I'm going to go ahead and turn this into an a cubed. I know this can be a little bit tricky, but if you think about it, what we're doing is we're just combining everything so that we have a common denominator. So I'm going to multiply all these terms together. So I have 2 times 3. So that's going to be 12. And then I have a cubed. Okay, so that's the common denominator. So I like to think of this as like kind of being my goal, right? I want to take these denominators and turn them into 12a cubed so that I have my like denominators. So now next thing I need to do is I need to go through all of these fractions and multiply by some form of 1. Okay, same numerator, same denominator, so that I get my 12a cubed. Well, from 4a squared, I need to multiply 3a, right? If I multiply denominator by 3a, I need to multiply numerator by 3a. Okay, let's go to the next fraction. So I have 5b in my numerator, 3a in the denominator. What's missing here? So to get 3a to become 12a cubed, I need to multiply by 4 and a squared, right? So 4a squared in numerator, denominator. Okay, final fraction, that should be a minus. That's minus 1 over 6a cubed. Okay, let's think about what's missing here. I want it to turn into 12a cubed. What I need to multiply by is 2, right? So numerator and denominator get multiplied by 2. So now I just go ahead and multiply what I've written out. So 3b squared times 3a is going to be 9ab squared. And then the denominator will just multiply to 12a cubed. Okay, and that's plus 5b times 4a squared is going to be 20a squared b. And that's over 12a cubed. And then minus, we have 2 times 1, which is just 2, and that's over 12a cubed. Okay, so my final answer is going to be 9ab squared plus 20a squared b minus 2 over 12a cubed. Okay, I can't simplify this. I can't factor anything out, so that is already in fully simplified form, right? Because if I check the numerator, there's no GCF that I can pull out, so I'm just going to leave it like that. So now you can go ahead and pause the video and try doing this example on your own. So here, notice the denominators I factored to 3 times 5a cubed b squared, and then this became 2 times 5ab squared. So I have 3 times, so like I said, I just, copy that first denominator, 3 times 5a cubed b squared. Then I think about, well, what's missing, right? So if I go here, I don't have a 2, so I need to add that in. A, I already have, and then b squared I already have written down. So I just go ahead now and multiply these together. 3 times 5 times 2 gives me 30, and then I have a cubed b squared, okay? So now if I look at these denominators, I want to multiply what's missing to turn into 30a cubed b squared. So here I multiply by 2 over 2, here I multiply by 3a squared over 3a squared. When I multiply by the 2 here, that 2 needs to distribute, okay? Because this is a little bit different because that numerator is a binomial. So when I do that, that gives me 2a squared minus 12, right? And then here, when I multiply by 3, 3 times 3a squared is just 9a squared. So I went ahead and added my numerators together, okay? I'm over on this next slide. So when I add my numerators together, I get 2a squared and then 9a squared and then minus 12, okay? And that's over the common denominator, 30a cubed b squared. Here I can actually simplify because 2a squared plus 9a squared is 11a squared, and then I have my minus 12, and that's over the common denominator. There's nothing I can factor out to simplify any further, so I'm going to leave my answer like that. So now let's try this example. So once again here, we don't have a common denominator, right? And neither of these denominators can be factored, right? They're just binomials. So the way to get a common denominator here is just actually to multiply the denominators together. So we're just going to multiply x minus 3 times x plus 2. Okay, so since that's the common denominator in this first rational expression, I need to multiply the missing factor, right? The x plus 2 over x plus 2. In the second rational expression, I'm going to multiply by the other missing factor, which is x minus 3 over x minus 3. Okay, so here I'm going to need to distribute because I'm multiplying a binomial by a constant, and I'm going to put that over my common denominator. And then I have minus, and then that's going to be 9 times x minus 3 and over x plus 2 times x minus 3. Okay, so now let's go ahead and distribute and multiply these out. So I'm going to end up getting 6x plus 12, okay, and then minus, I'm going to put all of this in parentheses because that subtraction is going to distribute there. So I have 9 times x, which is 9x, and then minus 9 times 3, which is 27. And that's all over the common denominator, which is x plus 2 times x minus 3. I'm just going to go ahead and distribute that negative so I can go ahead and take care of that. So I have 6x plus 12 minus 9x and then plus 27. And that's over x plus 2 times x minus 3. Okay, so let's go ahead and combine the like terms. So here I have a 6x and a minus 9x. So that's going to give me minus 3x plus, and then I have 12 and 27. So that is going to give me 39. And that's going to be over x plus 2 times x minus 3. So I could try factoring this to see if I can get anything to cancel, but you'll see that we actually can't, right? So if we have x plus 2 times x minus 3, Even if I factor the numerator, I just get negative 3 times x minus 13 over x plus 2 times x minus 3, and really nothing really will cancel there, okay? So that's already in simplified form. Okay, so now let's try this example. So here, once again, we have unlike denominators, right? So we need to go ahead and factor everything. So we have 2x plus 3 over x minus 4, and then plus x minus 1 over, and then I'm going to factor that denominator. So I'm going to assume y'all already know how to factor. So I'm just going to write it as x plus 4 times x minus 2. So the common denominator, I'm just going to write the first denominator, right, x minus 4, and then add in any missing factors from here. So the missing factors will be x plus 4 and x minus 2, okay? Be careful with the signs. A lot of people will think since we have an x minus 4, that's already taken care of, but this is actually an x plus 4. That's why I need to add in that factor. So actually, in order to get the common denominator, that first fraction, I'm going to need to multiply by 2 missing factors because I have an x plus 4 and an x minus 2 that are missing, right? So I'm going to multiply the numerator and denominator by that. And then I'm going to add it to my second rational expression, right? X plus 4 times x minus 2. And then here, at least I only have one missing factor. So I'm going to multiply by x minus 4 over x minus 4. Okay, so now let's multiply everything. So we have 2x plus 3 times x plus 4 times x minus 2. And that's going to be over x minus 4 times x plus 4 times x minus 2, right? Our common denominator. And then plus, I have x minus 1 times x minus 4 over, once again, we have our common denominator, x minus 4 times x plus 4 times x minus 2. Okay, so now I'm going to go ahead and just multiply a bunch of binomials, and then I'm going to simplify wherever possible. Okay, so I'm going to go over to the next slide. And here, when I multiply 3 binomials together, I know it can be kind of overwhelming, but my strategy here is just to do them 2 at a time, okay? So I'm going to do these first 2 binomials and then take my product and multiply by x minus 2. So if I use FOIL on the first 2, right, I do 2x times x, so that's 2x squared. The outside, 2x times 4 gives me 8x. And the inside, 3 times x gives me plus 3x, and then 3 times 4 gives me 12, okay? And then that's going to be eventually multiplied by x minus 2. And then here in the denominator, I have my common denominator, x minus 4 times x plus 4 times x minus 2. Okay, so now let's FOIL the second one, right? This numerator here, I just have 2 binomials. So if I FOIL that, I get first times first, so that's x squared. Outside, negative 4 times x, so minus 4x. Inside, negative 1 times x, so minus 1x. And then last times last, negative 1 times negative 4, which is positive 4. And that's all over the common denominator. So let's simplify now everything that we have. So this first numerator here, I can actually combine the 8x and 3x. So I have 2x squared plus 11x plus 12, and that's still going to be multiplied by x minus 2. So when I go ahead and multiply that x minus 2, I'm going to get 2x cubed plus 11x squared plus 12x, right? I'm first multiplying by x. Now I multiply everything by minus 2. So I have minus 4x squared minus 22x minus 24. So let's combine like terms. So I have 2x cubed. 11x squared minus 4x squared is plus 7x squared. 12x minus 22x is minus 10x. And then I have minus 24. And I'm going to put that all over my common denominator, x minus 4 times x plus 4 times x minus 2. And then now let's go to the second fraction and simplify. Here, these 2 terms will combine. So I have x squared minus 5x plus 4, and that's all still going to be over my common denominator. So now, since I have a common denominator and everything's simplified, I'm going to combine my numerators. So when I do that, I get 2x cubed, right, plus 7x squared. There's an x squared over here. So 7x squared and x squared is going to give me 8x squared. Minus 10x and minus 5x is going to be minus 15x. And then minus 24 and plus 4 is going to give me minus 20. And that is all going to be over my common denominator, x minus 4 times x plus 4 times x minus 2. So nothing here can be simplified, so I'm just going to leave this like this rational expression. Okay, so now you can go ahead and pause the video and try doing this example on your own. So here you can notice that the second numerator will factor into x plus 2 times x plus 3. So my common denominator, right, I'm just going to go ahead and copy my first denominator, which is x plus 2, and then I add in the missing factor, which is x plus 3. So when I go ahead and multiply everything and simplify, I end up with 4x plus 10 over x plus 2 times x plus 3. Nothing here is going to simplify. So now finally, let's try this one. This is an interesting problem because you can see here I have the difference of squares. And